The universe operates on a set of invisible, rigid rules that dictate everything from cosmic dust. These laws govern the drifting of celestial bodies and the precise trajectory of a soaring rocket. Sir Isaac Newton codified these fundamental principles over 3 centuries ago in his legendary scientific works. He provided us with a robust framework to understand the complex mechanics of the physical world. The first law, known as the law of inertia, establishes that objects are inherently quite lazy. They remain at rest or in constant motion unless an external force intervenes to change them. This explains why a soccer ball stays perfectly put until a player delivers a forceful kick. It also clarifies why a passenger jerks forward when a car brakes suddenly on the road. Inertia is a fundamental property of matter, existing in every single atom of the known universe. It requires us to use seat belts to counteract our own tendency to keep moving when braking. By recognizing these invisible forces, we begin to see that motion is never truly random today. Instead, it is a predictable consequence of the interactions between various objects and external forces applied. Every movement we witness in our daily lives is governed by these quiet yet powerful rules. From the falling of a leaf to the orbit of planets, the laws remain constant everywhere. Newton unveiled the hidden architecture of reality, allowing us to peer into the mechanics of nature. We observe the world through the lens of inertia, noticing how objects resist any sudden change. A book sitting on a table will remain unveiled forever unless a hand moves it away. A stone rolling across a field will eventually stop due to the invisible force of friction. Without these laws, our understanding of the physical environment would be nothing but a chaotic blur. Instead, we find order, structure, and a deep mathematical beauty in the way things move around. The universe acts as a grand machine, ticking along with precision and unwavering, silent, logical consistency. We are mere observers of this dance, yet we hold the keys to predict its rhythm. Each interaction is a dialogue between mass and force, played out on the stage of space. We see the soccer ball resting on the grass, waiting for a kick to break inertia. We feel the jolt of the car, a physical reminder of our body's desire to continue. These experiences are not accidents. They are the direct results of Newton's profound and elegant laws. The invisible rules bind the stars and the dust into a single, cohesive, and understandable narrative. We navigate our lives within these boundaries, constantly interacting with the forces that shape our path. Every step we take is a testament to the law of inertia and its persistent influence. The world is a laboratory where these principles are tested and proven with every passing second. Consider the stillness of a pond where a leaf floats without any desire to move. It waits for the gentle breeze to act as the force that disturbs its quiet state. This is the essence of inertia, the stubborn refusal of matter to change its current state. Whether an object is resting or moving, it demands an external push to alter its course. We see this in the way a hockey puck glides effortlessly across the smooth, frozen ice. It would continue sliding forever if not for the friction of the ice and air. Newton's brilliance was in recognizing that rest and motion are 2 sides of the same coin. Both states require an unbalanced force to break the cycle of their current, steady existence. Imagine a train traveling at high speed, carrying passengers who are also moving just as fast. If the train stops abruptly, the passengers continue their journey forward, defying the sudden halt. This is why safety engineers design vehicles with the principles of inertia at the very forefront. They understand that the body inside the vehicle is a separate entity obeying its own laws. It is a fascinating dance between the object and the forces that seek to control it. We are constantly learning how to manipulate these forces to build better, safer, and faster machines. From the simple bicycle to the complex spacecraft, the law of inertia remains our constant guide. It is the silent partner in every mechanical endeavor we undertake in our modern, busy lives. When we push a heavy door, we are engaging in a battle against its own inertia. When we catch a ball, we are exerting the force needed to stop its persistent motion. These mundane tasks are actually profound demonstrations of the fundamental physics that govern our vast universe. We are surrounded by evidence of Newton's genius, hidden in plain sight within every single movement. The more we observe, the more we appreciate the elegance of these simple yet powerful rules. They provide a sense of comfort in a world that often feels unpredictable and very complex. By mastering these laws, we gain a deeper insight into the mechanics of our own existence. We learn to respect the power of inertia and the necessity of force in our lives. Every object has a story to tell, and that story is written in the language of motion. Newton gave us the alphabet to read that story and understand the logic of the cosmos. As we continue our journey, we will see how these laws expand into even greater complexities. For now, let us appreciate the beauty of the first law and its quiet, constant influence. It is the foundation upon which all of physics is built, a cornerstone of human knowledge. With this understanding, we are ready to explore the deeper math behind the forces of motion. Building upon the concept of inertia, the second and third laws provide the essential mathematical tools. These principles grant us the power to master the complex physical matrix of our daily lives. Newton's second law, expressed as force equals mass times acceleration, dictates the mechanics of all motion. It clarifies that the effort required to move any object is directly proportional to its mass. A heavy, lumbering truck requires significantly more power to accelerate than a small, agile car. This simple observation illustrates that mass acts as a stubborn resistance to any sudden acceleration. Finally, the third law introduces the profound concept of action and reaction to our physical understanding. It states that for every single force applied, there is an equal and opposite response. Whether you are walking across a room, swimming through water, or launching a rocket into space, you are constantly relying on the ground or the atmosphere to push back against your force. Understanding these three laws transforms the world from a chaotic, confusing blur into a logical environment. It provides a structured framework, empowering us to calculate, predict, and manipulate the motion of existence. We see the world not as random events, but as a series of predictable physical interactions. Every movement we make is governed by these invisible, rigid rules established centuries ago by Newton. By mastering these equations, humanity has unlocked the ability to traverse the stars and beyond. The heavy truck accelerates slowly because its massive frame resists the change in its current state. The small car leaps forward with ease, demonstrating how mass dictates the requirements for applied force. When you push against the earth pushes back with an identical, invisible, reactive force. This reciprocal relationship is the secret engine behind every step we take on solid ground. Without this balance of forces, walking would be impossible and our world would lack stability. The rocket engine expels gas downward, and the resulting reaction force propels the craft upward. This elegant dance of action and reaction defines the trajectory of every object in motion. We are no longer mere observers of the physical world, but active participants in its mechanics. The laws of physics are the invisible threads that weave together the tapestry of our reality. By applying these mathematical truths, we can engineer solutions to the most complex physical challenges. From the smallest grain of sand to the largest planet, these rules remain absolute and unwavering. Newton's legacy is the clarity he brought to the chaotic motion of the natural universe. We now possess the language to describe the hidden forces that shape our very existence. The second law quantifies the struggle between mass and acceleration in every single physical interaction. The third law reveals the hidden symmetry that exists within every push, pull, and movement. These laws are the foundation upon which all modern science and engineering are firmly built. They allow us to look at a moving object and calculate its future path with precision. We can predict exactly how much force is needed to move a heavy, stationary object. We can understand why a swimmer moves forward by pushing the water backward with force. The universe is not a mystery to be feared, but a puzzle to be solved. With these tools, we navigate the complexities of motion with confidence and deep scientific understanding. The physical matrix is revealed as a predictable, structured system governed by these three laws. Every action we take is a testament to the enduring power of these fundamental principles. We are empowered by the knowledge that the universe follows a logical and consistent path. The motion that defines our existence is now a subject of our own deliberate calculation. As we move through the world, we are constantly testing and confirming these ancient laws. The resistance of mass and the reaction of forces are our constant, silent companions daily. We use these laws to build bridges, design vehicles, and explore the vast cosmic expanse. The invisible rules are the architects of our technological progress and our scientific future. They turn the blur of motion into a clear, understandable sequence of cause and effect. Newton's genius provides the key to unlocking the secrets of the physical world around us. We stand on the shoulders of giants, looking out at a universe defined by order. The laws of motion are the heartbeat of the physical world, steady and always present. They dictate the rhythm of our lives, from the smallest step to the grandest launch. We are the masters of our motion because we understand the rules that govern it. The second law is the bridge between the heavy and the light, the slow and fast. The third law is the bridge between the actor and the reactor, the push and pull. Together, they furnish a complete picture of how the universe behaves under our careful observation. We find meaning in the predictability of these interactions as we navigate our daily life. The physical world is a testament to the elegance of these simple yet powerful rules. We continue to explore, to calculate, and to manipulate the motion that defines our reality. The invisible rules of Newton remain the guiding light for all human discovery and innovation. They are the foundation of our understanding, the bedrock of our scientific and physical truth. In this structured environment, we find the freedom to dream, to build, and to reach. The universe is governed by laws that we have finally learned to read and apply.